Okay, so this section has to deal with comparing two means, or using, in this particular video, the two-sample t-statistic. So very similar to section 10.1 where you were comparing two proportions, now we're going to compare two means, which is still very similar to what we've been doing in our units. Okay, so the very first thing, just a refresher from your reading, is remember you can determine what the shape, center, and spread is from a sampling distribution. Make sure you read this part over in your textbook, but it just states that you have your shape from two totally different populations, each with their own mean and each with their own standard deviation. They both have simple random samples independent of each other. Okay, so you have your shape of the population distributions are normal, the sampling distribution of x sub 1, x bar minus x sub bar sub 2 is normal. In other cases, you may have to also look at what the sample size is for both to determine if it is large enough, to determine if it's a normal shape. Okay, the center is the mean of your differences. So we end up having our x bar sub 1 minus x bar sub 2 is actually mean sub 1 minus mean sub 2. In the spread, remember, we're using the standard deviation formula where it's standard deviation squared over your sample size, but we have to add them together because, again, we have two populations, and you want to take the square root of that sum and then make sure it's for no more than 10% of the population. Okay, the other big piece here, it's just like with all of our other tests or conditions for inference or intervals, you have the same thing here, where when you're doing means, you still have to have two independent random samples or from two groups in a randomized experiment. The 10% condition must be met, and the normal or large counts condition must be met, where remember instead you're going to take your sample size and compare it to 30, and if it's greater than or equal to 30, you're all set, it should be normal. If it's not, then you have to use a graph to assess the normality of the population. If there's any strong skewness or outliers, that means remember that it is not normal and you can't go further with the T procedures. Just as a little side note, when we start getting into doing this, you're really going to want to use your graphing calculator for it because the formulas are very long and tedious, and you can make careless mistakes in your calculator. The other part that's important for you to know is when we start getting into using degrees of freedom, because we're dealing with t intervals, you want to look at both of your samples, but you want to do the degrees of freedom for the smaller of the two. So depending on what you're going to have for your sample sizes will determine which degree of freedom you're going to want to use. So let's get into an example. So let's say that we have Ashton and Olivia wanted to know if generic chocolate chip cookies have as many chocolate chips as name brand chocolate chip cookies on average. To investigate, they randomly selected 10 bags of Chips Ahoy cookies and 10 bags of Great Value cookies. Remember, that's a Walmart's brand. And randomly selected one cookie from each bag. Then they carefully broke apart each cookie and counted the number of chocolate chips. And here you have a table with all of the values. We want to construct and interpret a 99% confidence interval for the difference in the mean number of chocolate chips in Chips Ahoy and Great Value cookies. So remember, when it says to construct and interpret, that means you need to do the four-step process. Remember, you're not going to be told anymore to do the four-step process. They're going to assume that you know it. So first step, state. We want to estimate the mean difference. Okay, so mu1 minus mu2 at the 99% confidence level. You have to define what mu1 and mu2 both are, where mu1 is the true mean number of chocolate chips in Chips Ahoy cookies, and mu2 is the true mean number of chocolate chips in Great Value cookies. Okay, so then we have to get into our plan. Now plan, remember, that's where you're going to tell them what you're doing. So are you doing an interval, or are you doing a test, and then that you're meeting conditions. So if the conditions are met, we will calculate a two-sample t interval for mu1 minus mu2. Random, the data come from two independent random samples. The 10% condition is met for both. And the large counts, because each sample was 10, we actually have to look at the graph to determine if it's normal. So here off to the side, you can see that I have, I made a box and whisker plot, actually a double box and whisker plot on my graphing calculator and transferred it onto my paper. Make sure, remember, that you put the graph when you are assessing normality for large counts, if it's less than or equal to 30. If it's less than 30, so that you can have proof. Because there's no outliers, neither graph looks like it's strong or in skewness, we can continue going with our T procedures. Okay, now we have to do the do part. So pull out your information that we were told before, which was X bar sub 1 is 18.4, and the standard deviation of the Chips Ahoy essentially is 1.78. Now, those weren't given to you, but remember you have the information from up above in a table, so you can go into doing one-bar stats and you can get the mean and the standard deviation for each type of cookie, which is essentially what I did here. Okay, your degrees of freedom, you're going to want to pull those out because you're doing a t-distribution. Remember, it's 10 minus 1, which is 9. They both happen to be 10, so we don't have to deal with taking either of the smaller. And we're going to use a table and pull out with a 90% confidence that our T star is 3.250. Okay, so let's set up our confidence interval, or what we would write out for our steps if we were showing our work. So remember, we're going to do the difference of the means, which is our statistic, so 18.4 minus 19.4, plus or minus the critical value, which we found from our table was 3.250, times our standard deviation of both. So remember, we want to have the large square root of 1.78 squared. Remember, we don't know the population standard deviation, so we're using the sample's standard deviation over the sample size of 10, plus 3.60, because that's our other standard deviation from our other sample, over 10. Okay, you go and you plug that into your calculator. You end up getting here -1 plus or minus 4.13, okay, which gives you your interval of -5.13 and 3.13. Okay, so here you have what your interval is if we were doing it out by hand. If you go over and use your calculator instead, it's actually a lot easier for you. So you go over and you hit Stat. You go over to tests, which is where all of our interval tests are also found. Okay, we have to find where it says 2 sample t interval. So it's not on this screen, so we have to go further down. And we have here at number 10, 2 sample t interval. So hit enter. Now, because we put the data into our calculator, we were given a table, we're going to select the data piece. If you had been given the mean and the standard deviation instead, you would want to just choose the stats piece here, and you'll notice that the screen changes. Okay, so we're going to do the data. We're going to do of list 1 and list 2, frequency of 1 and 1, and our confidence interval in this case is 0.99. Always leave pooled selected as no, and for those of you with the older calculator, you may have to hit down arrow again to get to calculate. So then we hit calculate. It takes a minute or two to just wait in your calculator. And here you're going to see that we have our interval here of -4.814 and 2.8138. Now remember, those are going to be a little different because the calculator is more exact. It's using a different level of degree of freedom than what we used, and it makes it a lot more concrete of an answer than what we found. Ours is more of an estimation. This is a little more exact than that. You'll also see here that they have the mean and the standard deviation that we found. It's using a degree of freedom of 13, whereas we used a degree of freedom of 9, okay? And you'll see that here you have your 2 sample sizes for it. So either answer is correct. Just remember, if you're using the calculator method, just write down what exactly you're using for your numbers so that they'll know. Also pull out, if you're writing this as your interval, what the degrees of freedom was that was used, and it was 13.15, so that if your AP reader doesn't know where that number came from, they at least know that, okay, you're using a different degree of freedom than what it would be if you were doing it by hand. Okay, so after we go through and do our do piece, remember you have to do your conclude. So remember, compare to see is that number or what our interval is, and write your statement. So we are 99% confident that the interval from -4.81 to 2.81 captures the true difference in the mean number of chocolate chips in Chips Ahoy and Great Value cookies. Remember, make sure you're using the word captures or contains, and we're talking about the true difference in means. So make sure you're including the difference in the means and what it is that we're talking about. Okay, so does your interval provide convincing evidence that there is a difference in the mean number of chocolate chips? So remember, we can use the confidence intervals and also to find out if there is convincing evidence. So is 0 in that interval, meaning for the difference? Okay, no, there is not convincing evidence that there is a difference in the mean number of chocolate chips in Chips Ahoy and Great Value chocolate chip cookies. Okay, so doing the confidence intervals for T is not as different really than what we did in the previous section for Z's. The only difference here now, remember, is your standard deviation formula has changed, and instead of doing Z intervals, we're doing T intervals, so you're not going to use necessarily the same tables. Okay, so the next video will be on doing the confidence tests for T tests.